Hello, this is Team Turquoise in cohort 58. We will be reviewing virtual retinal displays with you. Um, Listed below are the names of the individuals within our group, and they are listed in order of presentation from left to right. To begin with for today, we're going to go through a background of what virtual retinal displays are. Next, we will take a look at the applications in several different industries. We'll look at the medical industry, the entertainment industry, military sector, and the business sector. And lastly, we will cover some disadvantages of virtual retinal displays. Background. So virtual retinal displays began as a possible way to replace helmet-mounted displays. What differentiates a VRD, or virtual retinal display, image is that the image is projected directly onto the retina as opposed to some other forms of virtual reality where the image is projected instead on a screen. The main advantage to this is that you get a better quality of the image by displaying the image directly on the retina as opposed to on a display.
Avigant Glyph takes advantage of a virtual retinal display to transmit vivid, lifelike images directly to the eye. The image begins with a low-powered LED. After passing through a first set of optics, the light is reflected off a micro-mirror array, 2 million mirrors that shape the light into an image fit for the eye. The stream is then focused through a second set of optics and projected directly onto the retina, mimicking the way we receive light reflected off objects in our everyday environment. Glyph creates an image of extraordinary clarity, sharper and more realistic than current conventional display technologies, in a more natural way, without a screen. Enhance movies, gaming, or any media of your choice. Simply turn it on and enjoy the show.
Medical applications. There are several different applications that can be used in the medical industry. First would be as a therapy for patients that are recovering or coping with a long-term illness. An example of this would be helping patients overcome phobias by exposing these patients to displays of the specific subject matter of their phobia that they cannot escape. A specific example of this would be arachnophobia, or fear of spiders. So in this example, a patient would be exposed to images of a spider, allowing them to get accustomed to visually looking at spiders close up and not being able to run away or to escape from it, allowing themselves to become more accustomed to viewing a spider. Also, VRDs are being explored as a tool to assist in pain relief during painful procedures. So patients who are undergoing certain painful treatments would view various images using VRD, and they would be viewing virtual reality worlds or images that would help to take their mind off of the physical pain that they were feeling, in the overall hopes to moderate and decrease the pain that is felt. Next, for education or training tools, VRDs are being explored in being used as surgical simulations, very similar to the simulations that are done in the aviation industry that pilots go through prior to flying physical planes. Today, the surgical training that doctors go through is done primarily on actual patients, but VRD would decrease the need to train on live patients and overall decreasing risk that those patients are taking on. Lastly, there's a medical instrumentation for procedures that VRD could be implemented in. VRD technology can be used in a small scope in patients to help detect cancers that previously were extremely difficult to detect early on, to actually be able to view those areas and get better, reliable imaging to diagnose the cancer earlier than it's done today. The specific cancers such as pancreatic cancer, that is usually very difficult to diagnose early on, and is a very aggressive cancer, could be foreseen or detected sooner rather than later by using this specific type of scope, using the virtual retinal display technology. This could be done through a less invasive treatment than other methods that are used today.
In the entertainment industry, virtual retinal displays has mainly been used in the past for virtual reality arcades, where most of the time, we're kind of example would be kind of the beachhead games that you see, whether like Dave and Buster's or Jillian's or some type or that type of establishment. Okay, today VR I guess virtual retinal displays in the entertainment industry are still mostly focused on video games, but they can also focus on other things, such as the Oculus Rift has an app that allows users to watch full-length feature films, simulating the experience of being in the theater without actually being in a movie theater. Okay. So, providing users with virtual reality experience while playing video games. Okay, we have devices today such as the Samsung Gear VR, the Oculus DK2, aka the Oculus Rift, and Project Morpheus from Sony, that accomplish this. Samsung Gear VR accomplishes this by it's a headset that allows the users to control the cursor by moving their head and clicking by using a touchpad over the right temple, and you can download video games through this, and it requires a $6 controller for the games though, but you can still play games on it. Project Morpheus from Sony also does this. It works in tandem with the DualShock 4 controller and the PlayStation Move wand to deliver a virtual reality gaming experience. And it's Sony's take at virtual reality. Okay, the Oculus DK2, the Oculus Rift, also does this as well. Creating a projection screen using a cellular device. Okay, we have things like Google Cardboard that allows the user to turn their smartphone into a virtual reality device, and it can be made with 3 pieces of cardboard, a rubber band, magnets, 2 lenses, Velcro, and a smartphone, and it's defined as the no-frills version of VR. Okay. And last but not least, it allows developers to map spaces in 3D today. All right, today, a device currently being made called Project Tango uses a tablet and a smartphone to map spaces in 3D, and the price for that is $512 for consumers, but it is intended for developers.
virtual retinal display to project an image directly onto the retina. The military has been able to reduce the risk of eye strain from wearing night goggles by basically eliminating the need to stare through a screen or through a device and look directly at an image. Instead, the image is projected onto the retina, which does not cause any eye strain. This technology has also become very useful in flight missions to reduce danger to pilots by allowing pilots to view vital mission data with a clear and sharp image, which allows them to view all of the settings surrounding a certain mission and better prepares them for the mission, which has created overall better mission performance. This technology has also been used for thermal imaging by allowing a sharp or clear image of the surroundings during a mission in simulations and in training. And for training purposes, the virtual retinal display has been able to create the image of real life or virtual reality for whatever would be present during a mission, which prepared military personnel for going into the mission.
So who uses this technology today? Well, the National Football League has just begun using this technology with 6 different NFL teams along with several college teams using one of these tools. Years ago, players were receiving about 300-page playbooks, then it migrated to DVDs, then iPads. Now they get to use VR systems or virtual reality to actually learn quicker and more efficiently. I work in the power industry, and we have used similar devices to teach employees how to use different field devices in an office setting. So by putting on this headset, employees are able to open and close switches using a control panel, just like they would in the field with virtual technology. So what are some other reasons for this technology? Let's talk about some of the benefits. Costs are decreasing. It's much easier to deploy virtual training rather than in-class training. VRD technology is much safer, not having to train in dangerous environments as well. Since classroom training would not be needed, scheduling training for employees could happen much quicker. You don't have to get everybody together at the same time. Lower power consumption compared to traditional media displays. Projector screens or large plasma screens are much more expensive, using more power. Smaller spaces to implement training rather than large training facilities. These devices are compatible with any media device using a high-definition media interface, or, as we all know it, an HDMI cable, so they're extremely versatile. It's a very mobile device, even when compared to today's tablet. Privacy is greatly increased from traditional computers, as the screen can only be seen by the user. Working in public on sensitive information will no longer be an issue, whether it's on a park bench or on an airplane. According to different published reports in the news, this market is projected to reach almost $6 billion by 2020. Lastly, let's discuss the disadvantages of using the technology in the virtual retinal display. It could cause long-term damage to the eye since it's a new technology. This is still unknown. In order to use this device, you must wear a helmet or a set of goggles. Although several improvements have been made to this device, discomfort is still an issue. It can also be quite expensive to customize. The technology in the device could be used against us through military use. Images could be distorted due to the different types of display that are out there. And although there are some disadvantages, I really think several industries are heading in this direction. It's an exciting time. This could be the next technology that shapes our society.